Hello geometry, and welcome to 6.4, the triangle mid-segment theorem. Alright, so what is a mid-segment? We talked about this in the first section, but let's revisit what a mid-segment is. It connects the midpoints of the sides of a triangle. So you can see these markings says D is that midpoint, and these markings over here let us know that E is that midpoint. And it turns out and then this would be the actual mid-segment between D and E. Now it turns out that when you have a mid-segment in a triangle, it actually has several properties. The first one, and we've already kind of got it marked here, is that the mid-segment is going to be parallel to the base, or that third side. The mid-segment is going to be parallel to the third side of the triangle. All right, so you have that these are going to be parallel, and then the consequence there is, notice you're going to have things like corresponding angles and same side interior angles. So you're going to still be utilizing those properties of parallel lines. The other property is that the mid-segment is going to be half as long as that third side. So it takes two mid-segments to equal the third side. So we can write this as the mid-segment is half the length of the third side. Third side of the triangle. Okay, so those are our two properties that we can utilize when we have a mid-segment. So let's practice with a few of those. So if I have this third side here is 28, then I know my mid-segment will be half of that. Pretty straightforward. And if my mid-segment is 15, then the third side will be twice that length, so that'll be 30. Over here, we see that since we know this is a mid-segment, we know that x has to equal 9 because E is a midpoint, and we know that these two lengths have to be the same. All right, so that seems pretty friendly. Now we are going to actually, within one example, prove these properties. All right, so in this triangle here, ABC, we want to show that the mid-segment is parallel to that third side, AC. Well, in order for things to be parallel, it means that their slopes will be the same. So let's find the slope of DE. The way we can do that is we can just, since we have it on a grid, let's just do rise over run. So 1, 2, 3, up 3 over 2. That means my slope of DE is 3/2. Now let's find the slope of that third side, and we can kind of do the same thing. I'm going to go up and over, so I'm going 1, 2, 3, 4, 5, 6 up, and 1, 2, 3, 4 over, and notice that reduces to 3/2. So therefore, we know that segment DE is parallel to segment AC. All right, so you're going to find the two slopes. You find the slopes are the same, therefore the lines are parallel. Now we want to show that DE is half of AC, and notice there's no line over it, so that means, and really there should be lines over these ones, so we're looking at the length of something, and to find the length of something, you have to use your distance formula. So the distance, DE, is going to be, we're going to be using our coordinates here. So the coordinate of D is 0, -1. The coordinate of E is 2, 2. And so if I'm finding the distance, I always like to set up my template first. So we're going to subtract the x values, 2 minus 0. It actually doesn't matter which order you do them in since you're going to square it. And then I subtract the y values, so 2 minus a negative 1. And that gives us 4. 2 squared is 4, plus 3 squared is 9. And that is the square root of 13. And we'll just leave it like that for a second. Now let's find the length of AC. So we'll set up our template here. Something squared plus something squared. So the coordinates for A are 1, negative 6, and C is 5, 0. So subtracting our x values, 5 minus 1, and subtracting the y values, negative 6 minus 0, that simplifies to 4 squared is 16, and 6 squared is 36. That is the square root of 52, which you can simplify. Square root of 4 times the square root of, whoops, I wrote the wrong number, square root of 13. And so 4 times 13, think of a deck of cards. That simplifies to 2 rad 13. So when you compare these two lengths, notice that AC is twice as long. Therefore, we have shown that DE is in fact half the length of AC. All right? So yes, all these distance formulas, slope, they do not go away, all those good algebra skills. All right, let's take a look at this example down here. So in the triangle QRS, we have A, B, and C are midpoints of the sides. So if AB here is 16, what is the length of QS? Well, that's going to be 16 and 16, which means this is twice as long. It's going to be 32. And then I'll try and color code these. When SR, which is over here, when SR is 68, what is the measure of CA? Well, that's going to be half as long, so that would be 34. And then lastly, if CA happened to be 3x minus 1, so here I have 3x minus 1, and SR happened to be 5x plus 4, what is the measure of CA? So in order to do that, we have to set up an equation. We know that it takes 2 mid-segments, so 2 times 3x minus 1, to equal that third side. And so now I can set these, I can distribute 6x minus 2, and subtracting 5x and adding 2 to the other side gives us that x is 6, but that doesn't answer our question. CA is 3x minus 1, so 3 times 6 minus 1 tells me that CA is 17. All right, and then our last one here involves QR. So QR is 5x plus 2, and I really should use a different color, but I'm running out of colors, you know. Here, I can use blue. All right, so QR is 5x plus 2, and then we have CB. Where's CB? There's CB is 2x plus 5. What is the measure of AR? Okay, well, realize that AR and CB are going to be the same length because AR is half of QR. But first we have to figure out what is X so we can figure that out. So once again, we take our mid-segment, CB, and we double it. So twice 2x plus 5 has to equal 5x plus 2. So we have 4x plus 10 equals 5x plus 2. So x equals 8, and when we plug it back into 2x plus 5, 2 times 8 plus 5 equals 21. So AR is a length of 21. All right, I hope this is going okay. And then this last one, which you would do on your own, what is the perimeter? And now there's several ways to go about doing this problem. I know that the perimeter of ABC, I should say perimeter of triangle ABC, is going to be 38 plus 45 plus 13, and that adds up to 96. So the perimeter of this small triangle, DEF, which is what we want, is going to be half of that. So that is going to be a distance of 48. We don't have any units, so we'll just say 48. So that would be the shortcut. You just find the big perimeter, and knowing that each one of these is half of the opposite side, you can just take half the other perimeter. It's easier because notice we have some odd numbers here, so to actually take the half and then you're adding halves, that's probably the easiest way to go.